We'll be starting in a few minutes. Let's wait for some more people to join. All right, guys. So am I audible? Yeah, I am. So this is the third series of our Logic Lounge. Today we will be discussing Codeforces round is 935. Wait, let me check. Yes, 945 Div.2. We'll be going through problems A to C. So first of all, a brief about ACM. So we are conducting this post-contest discussion for this summer, and the response till now has been tremendous. We thank you for that. So since we don't think many much और लोग आएंगे, so let's start with today's problem A. Let me share my screen. Yeah, wait. Hello, is my screen visible? Right. So, पहले, are you guys comfortable in both Hindi and English? If not, then let me see. Okay, okay. Still, I'll try my best. So, yesterday's problem A. So, a brief about yesterday's contest. How many of you actually gave it? Because, in my opinion, it was one of the tougher ones. Yeah, so many gave it. So, let's start with problem number A for yesterday. So, the problem was given two players. I hope that you have read the question because I won't be going over it very thoroughly. You have been given, so the brief about the question will be like something like this. You are given three numbers, which are P1, P2, and P3. Now that there's a condition which is given, which is that this has to hold. And you have to find the maximum number of draws. Okay, I'll go over the question once because it might get confusing. So the winner gets three friends have to play a game. The winner gets 2 points, while the loser gets 0. So 2-0 will be one case, and the other case will be a draw, in which both the players get 1 point. So same number player. Okay, that doesn't matter much. Now we have to find the maximum number of draws that could have happened and print it. So how do we get the maximum number of draws? That's the biggest question, right? So let's take a few dry run and let's try with that. So let's take this 1, 1, 2. So as you can see, the optimal amount of draws will be 2 for this. And if you see it intuitively, then you can see that, let's say that these two played draw for once, and then these two did. No, not these two, these two. Then you can say that their sum will be 1, 1, and 2. So it's pretty easy. Now, the question is asking for the maximum number of draws. Okay, so there will be like two cases. Case number 1, when P1 plus P2, that is these two smaller ones. Remember this condition, okay? This is less than P3. So let's take a example for that. For that we'll be taking 1, 1, 10. Okay, 1, 1, 10. This is a very good example. Or let's say 1, 4, 10. Okay, 1, 4, and 10. Now, what I want you guys to know is, let's take this, the biggest number, as a pivot. Like, we'll be subtracting these smaller numbers from this. For example, what I mean to say is that I'll be taking the smaller numbers, like here, 1 draw and 1 draw from here, and then 4 draws from here and 4 draws from here. So effectively, at the end, what we'll be left with is 0, 0, and here 5. Although this case is not optimal, I'll tell you why. This test case is not optimal. I'll tell you why. Okay. So it's not optimal because it's 0, 0, and 5. And if you guys know that there is only two cases, it can go either 2, 0 or 1, 1. So it's 0, 0, 5. So it can get to like 0, 0, 1, because after 2 wins, and then it will be left with 1. And this cannot go anywhere. So this case is not optimal. So one more thing that I would like to add is P1 plus P2 plus P3. This mod 2 should be equal to 0. Here it was not. So it was a wrong test case. Now let's get back to the original question. That would be, let me add a new page. So 1, 1, and 10. So if we were to maximize the number of draws, what it would be like? 1 here and 1 here. So 1 draw and 1 draw here and 1 draw here. So in total, after this, we would be left with something like 0, 0, and 8. And then 8, it's there. It can get 4 wins with any of the other player, and it's done. So if P1 plus P2 is less than P3, can I say that the answer will be equal to P1 plus P2, or the total number of draws? That is my answer. Total number of draws will be my answer, and the rest will be win. I don't care much. In fact, I can even say equal to it. This is one case. Now, what would happen if P1 plus P2 is greater than P3? Now comes the tricky part. Like an example I should take. Like this test case, 3, 4, and 5. 3, 4, and 5. P1 plus P2 is 7, so it's greater than 5. So what we would need to do here. Now, I told you guys to take this, the largest number, P3, as a kind of pivot, like you subtract the draws from it. Okay. So if you just keep on subtracting the draws like you did above, you can end up like you do 1 into 3 draws from here and 1 into 3 draws from here. So you end up at 0, 4, and 2. And then you go again that, yeah, I can do draw games with P2 and P3 also. So it would be like 0, 2, and 0. And you are left with 2. And 2, 0, you can say that P2 won once. So how many total draws was this? 3 times. And then from here into 2 times. So total 5. But This is not the optimal case. As you can see that it's saying it's 6. You can see that if you want to go ahead and do more, I mean, get 6 draws, you can get it very easily, like 2 draws from here. Okay. And let's say 3 draws from here. Okay. That will be equal to 5. So this one gets cancelled out. And then from here, you will be remaining with 1. And here you will be remaining with 1. And 1 and 1 more draw. So in total, 6 draws and no wins and losses. Here it was 5 draws. 5 draws plus 1 win or loss, win loss case. Okay. Now, how do you maximize the draw in this case also? How were we able to come up with this one? Now, what I would tend to do is, you have P1 and P2, okay, and P3. So try to make P1 equal to P2. It is possible. That is, what I want you to do is make P3 equal to P3, or assign P3 equal to P3 minus P2 minus P1. If you are able to do this, what would the resulting numbers look like? It would look something like, let's say, this one is something P1. Okay. Oh, wait. P1, and you subtracted this by P2 minus P1, and you came here and did that also. P2 is equal to P2. And this is P1, this is P2, and this is P3. So this is P2 minus P1. This much. Okay. So what I'm telling you to do is make these two equal. That is, bring these two equal here, and this part you subtract it from here also. That is, you are going to play the draw games with P2 and P3 for P2 minus P1 times. Okay, so it's going to look something like this afterwards. This is be this, and this may be somewhere this. Okay, so these two are equal. Now, once these two are equal, there's one more important observation to note here, that after doing this thing, P3 will always be even. If you want to prove it, I can tell you, like P3 minus P2 minus P1. This is even. This will be even. How do I tell you this? Like, let's say that this is even. If it's not even, I mean, if it's odd, then you simply return -1. Because think about it. If it were odd, what we will be doing after this is that we will be taking it in pairs and minusing it with this one. So P3 by 2 will be minused with P1. Okay. And same case is P2. P2 was reduced to P2 minus P1. P2 minus P1. P2 minus. That will be same P1 minus P3 by 2. So yes. If this part is even, then you go ahead and do. Let me show the code. It would be better actually that way. So if you see here, then what it was done, that P3 minus P2. If you look in the official editorial, then it was written something like P1 plus P2 plus P3. If it's not mod 2 is not equal to 0, then you return -1 simply. It's actually the same here also. Like if you take, let's If you actually run on a few test cases, you'll see that these two are the same, but that's not the case. The thing is, you go ahead and reduce. Actually, it would be more. To be honest, yesterday's A was a little bit tricky. If you were able to figure it out in O1 time complexity, kudos to you. But to be honest, it was a little bit tricky.
Yeah,
So
it
the
can be
gist would
proven
be
through
something like,
logic. Like there will be
yeah,
only if P1, P2 or P3 has one odd, then the other should also be odd, like it was given in the editorial. So when we will subtract, it will make the case even.
yeah. Actually, it was a bit of math actually. I mean, if you prove it through inequalities, it will get proven very easily. But I am not hitting it right now. So no worries. The thing is, there will be two test cases. Number one, P1 plus P2 is less than P3. In this case, your answer will simply be equal to P1 plus P2. The second test case will be when P1 plus P2 is greater than P3. So what you do here is, I told you, like this is this. You try to make these two, that is, these two same. So P2 minus P1, well, you will reduce P3 by P2 minus P1, okay? And once you do that, you will be left with P1 and P1, and the rest will be this. Then after that, you will go ahead and reduce, like one time you do a draw game with P1 and P3, then you do a draw game with P2 and P3. And you keep on doing this till you reach the end of P1. So it would look something like this, like at the end, it would be like 0, 0, and here will be some value. Okay. Now, if this value is odd, then you can obviously see that, like if it's odd, then you can't complete the game, like 2020, it can't go there. So you have to return -1, and that's why it was an early exit when I was checking for this. If it's even, you will be left here with even. Instead of odd, you will be left here with odd, and you are able to complete the game. But if it's odd, you return with -1. And hence it was like that. So this was my solution. It is very difficult, not difficult, rather difficult to let's say tell you guys how I did it, because I with a came with it. But as you can see that here this is the mod 2 early exit which I was telling you about. If you encounter this, that is if it's odd, you return -1. Now you go ahead and do this. If P1 plus P2 is less than P3, then your answer will be P1 plus P2. Else, that is if it's greater, you go ahead and do P2 minus P1. P2 minus P1, because this part I was telling you guys, you make it equal. So answer plus P2 minus P1. And once these two are equal, then you go ahead and what you have done. Uh, you reduce that by this, and basically the gist is this. You make them equal, and then one by one, you reduce them. So it will be like P3 by 2 for this guy and P3 by 2 for this guy. And you have to return their sum. So the final answer would be like min of, it was given in the editorial also, P1 plus P2 plus P3 by 2, comma, P1 plus P2. It would look something like this. So I tried my best explaining this to you, although I would arguably say that it was quite a bit difficult to understand if you did not solve it in contest. If you were able to solve it, I think it was pretty clear, but otherwise. Okay, so I'll let Nan tell for the B solution. Okay.
But yeah, how did you get the intuition for this mathematical approach?
Contest, during the contest, I was thinking, and then it just hit me. Actually, I was doing the inequality thing itself, okay, and that's where I came up with this part. Wait, let me share my screen again. Right, is it visible? Yep. So that's during the contest itself, I came up with this part and this part. And once I was up with this part, you can see that I have written a few, maybe more than a few redundant lines here. But this part was totally on the spot. This part I came up with using inequalities. So it's like standard in most of the Codeforces A rounds actually. Not standard, but many of the times the solution is like O of one approach, simple math problem. And that's how I approached it. I mean, many have solved this using DP also and many other things. You can use it, use for loops also and solve it because the constraints are very low. But in most of the contests in A problems, there exists a order of one solution most of the times. So I solved it using inequalities. I don't remember it now, although. So then start with the next solution.
अच्छा ठीक है. कल के कॉन्टेस्ट का बी प्रॉब्लम कितने लोगों ने सॉल्व किया है, मतलब एटलीस्ट अटेम्प्ट किया है सॉल्व करने को? अच्छा ठीक है. तो बी सवाल कल का थोड़ा ट्रिकी था, तो आई ट्राई माय बेस्ट टू एक्सप्लेन. तो एक बार स्क्रीन विजिबल है क्या सबको? अच्छा ठीक है. तो एक बार लैंग्वेज थोड़ा कॉम्प्लिकेटेड था, तो एकदम सिंपल भाषा में समझाने की कोशिश करता हूँ. ठीक है. ठीक है. तो क्वेश्चन में ये था कि तुम लोगों के पास एक इंटीजर n दिया रहेगा और एक एरे whose size is equal to n दिया रहेगा एज इनपुट. ठीक है. तो क्वेश्चन में ये था कि अच्छा ठीक है, क्वेश्चन समझने से पहले एक बार ये बता देता हूँ कि सब एरेस होते क्या है. ठीक है. तो मे बी मेनी पीपल माइट नॉट नो व्हाट सब एरेस आर. तो एक बार समझा देता हूँ. सब एरे है मतलब कि इफ यू आर ग्रुपिंग एलिमेंट्स टुगेदर, मतलब वन आफ्टर द अदर, दैट इज नोन एज अ सब एरे. ठीक है. तो in this case, we can have subarrays of size 1, where we're taking individual elements like this. We can have subarrays of size 2, where we're taking two elements together, one after the other. And as such, we can have subarray until size n, which is the entire subarray itself. So the question was asking key, find the smallest. One second. So the question was asking is find the smallest length of the subarray where each subarrays or is equal. Okay, so in this case, I will dry run and try to explain you. Okay, so for simplicity, let's just write the or of all the elements that is given here. For 0, it should be 0, 0, 0, the bitwise. For 1, I guess it should be 0, 0, 1. For 2, it should be 0, 1, 0. And for 3, it should be 0, 1, 1. Okay. I hope everybody understood till here. Has everybody understood? Okay. If you have any doubts, please feel free to ask. Okay. Okay. So this was given. Okay. So now let's start one by one. Okay. Let's dry run and check. Okay. Okay. So now we'll check subarrays of size 1 each individually. Okay. So the OR of this will be 0 itself, because obviously only one element, so you cannot OR it with any other element. So the OR will be 1. The OR of this will be 1. What the question was asking is ki the bitwise OR should be the same for all the subarrays. So our condition is broken here because the OR of the first subarray is 0 and the second subarray is 1 of length 1. So 1 cannot be the answer. So now let's try it with 2. Okay. So these will be the first two elements, 0 and 1. So what will be the OR of this? I guess for A, let's name it as A. So, so the OR of A will be what? 0 or 1. And I guess that should be equal to 0, 0, 1, or which is basically just 1. And then we have the next two elements, which is 1 and 3. The OR of these two elements will be what? Let's take that the second subarray as B, and B is basically your 1 or 3. So what will that be? That should be equal to, I guess, should be equal to 1, 1 or 3. So the constraint that was given that every subarray should have equal or, that is also broken here. So our size cannot be 2. Now let's check for 3, size 3, okay? So now our first subarray of size 3 will be 0, 1, 3, okay? I'll write it down here, just a second. The first subarray, which is, let's name it as A, will be OR of 0, 1, and 3. So that will be, I guess, should be equal to 3. Okay. Now let's take the second set of subarray, which is here 1, 3, and 2. Okay. So what will the OR of 1, 3, 2 give? Let me write it down here. Let's see. This, let's name it as B. B will be OR of 1, 3, and 2. The order of 1, 3, 2, as you guys know, should be 1, 1, or which is equal to 3. So our constraint key, every subarray should have equal or is still being fulfilled here. Let's check for the next set of subarray. In our case, will be, what will it be? It will be 3, 2, 2, correct? So let's check the, for 3, 2, 2. For C, it will be 3 or 2 or 2. So that I also assume should be equal to 1, 1, or which is 3 in our case. Okay. So if you check for each and every subarray of size 3, you will always get OR as 3 in this situation. Okay. So we can say that the smallest value of k for this question will be 3, and it is also clearly given in the question, the size 3. And if you want to cross check, that is given in the explanation. Okay, it will be 3. Now let's check for 4. Okay, so I'll just write it down. I hope you guys understood what is subarray. So I'll just write it down here quickly. Size of subarray 4 will take k equal to 4 here, which is the size. So the first will be 0 or of 1, first subarray. It will be 1 or 0, 1 or 3 or 2, and that will be equal to 3, should be equal to 3. Your second subarray, which is your 1 or 3 or 2. This should also be equal to 3. Okay. So here, if you're able to see, even for size k equal to 4, your condition that every subarray should have equal or will also hold true. Okay. So the claim I'm making here is for a k, any number k, okay, all the numbers after k, which is k plus 1 till n, will hold true. K here is your size of the subarray. In the sense here for size 3, it was holding true that every subarray has equal size. I proved that for size 4 also every subarray will have the same size, and so on and so forth you can prove. I'll give you a small example how. Let's say here I have marked this as A, the first subarray as A. Okay. I have marked the second subarray as B, this one as B. I have marked this subarray as C. Okay. And I have marked this subarray as D. Okay. Okay. Now I'll explain how I came up with the proof. Okay. So now you know that A, which is my OR of the first three elements, okay, should be equal to B, which is the OR of 210 in this case. And I also can say that my OR of C, which is the OR of 132, is equal to D, which is the OR of 103, as we saw here, because every subarray has equal OR. Okay. So now if A equals to B and C equals to D, I can also say that A is equal to C, because here every subarray has the same OR. And similarly, I can say OR of B is also equal to OR of D. It's fine until here. Okay. So now, if I'm able to understand this, I can also say that the OR of A or C will be equal to B or D, because in our case, this was 3, A and B both were 3, C and D both were 3, correct? Okay. So now, A or 3, 3 or 3 will be 3. In this case, should be 3. Okay. And your B or D should be 3 or 3, which is, should also be equal to 3 in our case. So, what is A or C? I'll explain to you once. So, our A is what? Is 0, 1, and 3 is our A. Okay. And what is our B here? Our B is 1, 3, and 2. Correct? So now if I'm taking OR of A and B, A and C, sorry, this is C as given here. I'm proving this, okay? So now what will be my A or C here? It will be basically OR of 0, 1, 3, 1, 3, and 2, okay? OR of all the elements, okay? It will be this. So I can say that OR of 1 and 3, and if I'm doing it OR of 1 and 3, these both when I'm taking OR, okay? Basically, I'm taking the OR of these four. I can say that will always be equal to whatever the result 1 and 3 will give me, the OR of 1 and 3 will give. Because 1 and 1, if you do OR, you'll always get 1. And 3 and 3, if you do OR, you'll always get 3. So this entire thing is just technically this 1 and 3, OR of 1 and 3. And our left elements were 0, and the other one was 2. And we get this as a result of A or C. Now, if you're able to see, A or C is basically the combination of the first four elements, correct? So I proved that if for size 3, which is K, our smallest K here, for every K bigger than 3, this condition will always hold, which is your, if it is constant for K, if I'm able to prove that for every subarray the OR is equal, for all K plus 1 or all K greater than K, I can prove that the condition will hold true. Okay. Has everybody understood? If any doubt, please ask. Hello. सबको समझ में आई है? If not, I'm ready to explain once again क्योंकि concept थोड़ा tricky था. तो किसी को समझ में नहीं आया तो I'll explain it again. ठीक है. तो since there's no response, I'll assume that सबको समझ में आया होगा. Okay. So ये सब ठीक था. Okay. No. There is this. तो तो जो जो ऑब्जर्वेशंस मिला था हम लोगों को सो फार वी विल राइट इट डाउन हियर सो दैट जब आंसर जब कोड एक्सप्लेन कर रहा तो आसानी होगा समझने में. तो बेसिकली फॉर के जो भी विच इज आवर स्मॉलेस्ट value of the subarray length, I can say that for all k plus 1, the condition of all subarray having equal or will hold. Okay. तो ये कंडीशन आई होप सो सबको समझ में आया होगा. नाउ और एक ठीक है. नाउ देखो तो सबएरे का जो साइज है इट कैन बी 1 और मैक्स टू मैक्स इट कैन बी n. ठीक है. तो लेट्स अज्यूम कि कोई आर आंसर के इन दिस केस सम आर्बिट्री नंबर मान ली कि x है एट दिस पॉइंट. ठीक है. क्या करते हैं वी नीड टू फाइंड दिस x. So there can be two ways of finding this. One, either you can do your normal linear search, which is iterate through each, and then the moment you get that your all subarrays are equal, or you can break and stop that this you tell that this is your smallest k, or else uh, we can do binary search. And binary search was supposed to be the method that you're supposed to apply to this because linear search I think gave clearly. So linear search you were not supposed to apply binary search. Now I'll explain how binary search in this case. Okay. So okay, let's say 1 and n is our low and high. This is our low and this is our high. Okay. Now let's say our mid is somewhere here. Okay. High and low, and this is our mid here. Okay. Now what this mid is telling is this should be the length of my subarray. Length of subarray. Okay. So subarray. Okay. And lowest one because each subarray can be of size 1 also. You're considering element by element. It can be that also. And n is because you can consider the entire subarray as just one subarray, or entire array subarray. So condition will always hold true for n. We know that much. Okay. So now we found mid. Okay. And now let's say this mid is something. Let's say k here. Okay. So now let's assume key for k, we have gotten the answer key for every subarray of length k, the OR has come out to be equal for every subarray. Okay. So if for k, we know that this holds true. So for everything other than k, bigger than k, we know it holds true from this observation that we got in the previous explanation. Okay. So you know that the answer is not here, the smallest value of k. So what we'll do is we'll shift our high to what? Mid minus 1. Because we know our range is somewhere here, the smallest value. High will be somewhere here, mid minus 1. Okay. Now again we do the same thing. We take the low and high, find mid, and let's say our mid comes somewhere here. Okay. Now for this value of k, let's say all subarrays of value k is not holding true. So we can say that for less than that, it will not hold true. Because if it's not holding true for k, Obviously, for smaller than it will not hold true, no? So what we'll do, we know that our answer is not behind this part. So we'll bring our low here, which is what? Mid plus 1. So that's how we have to apply binary search in this question. Uh, सबको समझ में आया कि how binary search is being applied? किसी को समझ में नहीं आया तो I'll explain again, क्योंकि tricky था थोड़ा, तो I hope कि सबको समझ में आया होगा. So if any doubt, please feel free to ask. Okay. So this was our second thing. Okay. So we got two observations from this. Our first observation was that if for size k subarray, all subarrays equal or then for all sizes greater than k, every subarray will have same order. ये था फर्स्ट ऑब्जर्वेशन. और सेकंड ऑब्जर्वेशन ये था कि we have to use binary search. और binary search कैसे I explained. तो होप सबको समझ में आया होगा. बस यही तो ऑब्जर्वेशन करना था. और बाइनरी सर्च के बाद कैसे इसको अप्रोच करते हैं वो एक बार सिंपल था, तो एक बार समझा देता हूँ. तो विल टेक द सेम एग्जांपल हियर. तो ये ऑब्जर्वेशन आई होप सबको समझ में आया होगा. नो, तो अब देखो, जीएसए में वी हैव अ वेरी इंपॉर्टेंट कॉन्सेप्ट कॉल्ड स्लाइडिंग विंडो. ठीक है. तो स्लाइडिंग विंडो में करते क्या है कि जैसे द वर्ड सजेस्ट एक विंडो बनाते हैं. ठीक है. इन दिस केस विल मेक फॉर 3, एक विंडो बनाते हैं और जो भी कैलकुलेशंस करना है ना विल डू विद इन दिस विंडो. ठीक है. मतलब बस 3 साइज के इस सब एरे में जो कैलकुलेशंस करना है हमको मतलब है, बाकी सब एरे से मतलब नहीं है फॉर द टाइमिंग. ठीक है. तो क्या हम करते हैं, और एक समझा देता हूँ. यहाँ गिवन है कि योर मैक्सिमम वैल्यू ऑफ द एलिमेंट एरे का हो सकता है 2:20. ठीक है. एक बिटवाइज का एक जल्दी से एक्सप्लेन कर देता हूँ. आई होप एवरीबॉडी विल अंडरस्टैंड. ठीक है. ठीक. तो देखिए, 2:0 अपना क्या होगा, 2:0 इज बेसिकली 1. और इसका जो बाइनरी रिप्रेजेंटेशन होगा क्या होगा, 1. 2:1 क्या होगा, इसका बाइनरी रिप्रेजेंटेशन 2 होगा, मतलब डेसिमल 2 होगा. और इसका बाइनरी होगा 10. 2:2 क्या होगा, बेसिकली 4. और 4 का बाइनरी रिप्रेजेंटेशन अपना होगा क्या, 100. ठीक है. तो इफ यू कीप सीइंग लाइक दिस, we'll get 8 here and the binary representation of this will be 100. ठीक है. So what we're doing is, जो initially 1 है, ठीक है, if we shift this place of 1 by let's say from here to here, okay, what are we doing, we are shifting the 1, we are doing left shift, which is basically from this position we are shifting it left to here. Okay. So what should it be, it will be 1 then 0. So we have shifted the place of 1 by 1. So which is basically we have done 1 left shift 1. So that will give us what? Which is 10 because we shifted the place by 1. So 1 will come here and 0 will come and they will get this. Okay. Similarly, if you check for 2:3, okay, how many places have we shifted 1? 1 should have been supposedly here. So we have shifted 1, 2, 3 times, correct? So we have shifted how many times? 1. We have shifted 3 times. This is your shift operator or left shift operator. What we're doing is we are shifting the position of 1 to the left by 3 times. Okay. In the constraint, it was given that the maximum size of the number that we can have is 2:20. So 2:20 is basically what? 1 left shift 20, correct? So which means max to max our element can have 20 bits, correct? Okay. So our third observation was the your elements at max can have 20 bits. Okay. So 20 bits. Okay. So now I'll explain the sliding window solution that I used here at least. Okay. So I told you that at max you can have 20 bits, and I showed you why also, because 2 raised to 20. So which means one left shift 20 is the max number you can have. And the interesting thing is it is not equal also, so it should be essentially lesser. So it should be 19 bits actually. So basically 1 raised to 19 bits it should have. Okay. So what we do is we create, in this case, subarray of an array of 20 size. Okay. 0 say 20. Okay. So 1, 2, dot dot dot, the rest of the array. Okay. And we fill all of it with 0 initially because we have nothing filled. Okay. So now what we'll do is we will calculate the bit of 0. So what is the binary representation of 0? Should be 1 second. I'll write it. Binary representation of 0 is 0, 0, 0. Binary representation of 1 is 0, 0, 1. Binary representation of 2 is 0, 1, 0. And that of 3 is 0, 1, 1. Yeah, 0, 1, 1. Okay. So that should be fine. Now, uh, yeah. So binary representation of 0 is 0. So basically, this 0, right, it represents the first bit, this was bit, the 0th bit. This one represents the second bit here, and this represents the third bit, like in this case. Okay. So now 0, 0, 0, it's fine. Now 1. The binary representation of 1 will be what? 0, 0, 1. So here what I'm doing is I'm storing the number of ones. Okay. Number of ones. Okay. So now for 1 it will be 0, 0, 1. So in the third place, okay, we'll have 1 here. Okay. Similarly, in the place of 2, in which location do we have the 0 here? In place of the second, so which means here we'll have, okay. And for 3, we'll have 0, 1, 1, which basically means in both this location and this position, I'll have two number of 1 bits. Correct? So our array will look something like this: 0, 2, 2, and then rest of them all are zeros. That is none of our concern. Okay. So now what we'll do is we had this subarray, right? And in that we got the answer as 0, 2, 2. What we'll do is we'll store this result somewhere. Okay. We'll store this result somewhere. And before that, one more thing. Uh, we know that in OR, either our answer can have a 0 bit or a 1 bit. It cannot have a 2, right? So if our answer, like in this case, is having a number greater or equal to 1, we can simply change this to 1. So which in this case will be 0, 1, 1. And then we'll have something like this. And we'll store this result in a set. I'll explain to you this via code. I think it will be easier. Okay. Okay. So I hope, okay, so I'll explain this concept via code. Here we took the input as simple, and then we kept the bits array of size 20. As I explained here, of size 20, we keep the bits array. Low we have taken as 1. I explained why, because you can have subarray of size 1, and high is n because the entire array itself is a subarray. Okay, and the initial answer will always be n because the entire or of this array will always be, there's only one array that you can compare, right? So you know that for size 8 you have one subarray, and since you have only one subarray, the answer will be confirmed. So here n, because now what I'm doing is I'm keeping a set. And why am I keeping a set here? Because I want to check for every window whether my or, the representation of or in the bit, in this bit array that I've created here, I want to check whether it's the same in all subarrays. Okay. If it's the same in all subarrays, I can say that in every subarray the or has been equal. So it can be a possible answer of mine. So that is why I'm keeping set to check key whether in every subarray I want to check whether my or is the same. So I'm keeping it in a set. So that okay. I'm taking mid, and this is because what I'm doing is I'm making sure that the bit subarray, right? It is filled with zeros initially because we don't have any what do you say? We don't have anything present right now. So all should be zero. Okay. So now, as I told here, in our case here, let's assume that the mid is 3 in this case. So 0, 1, and 3 will be the first set till mid. Till mid it will be 0, 1, 3. And why I'm doing 20 is because I told you, right, that for every your element, the max that you can have is 20 bits because it was given in the question. It can be of 20 bits, not more than that. Now I'll explain another concept. Just one. Okay. So I'll just write down the observations again. So first observation was, okay, plus one. Second is binary search. Third is 20 bits max. Okay. So now I'll take one example here. Let's say I have a random number here, which is, let's say in this case, let's say it is from the example we'll take. Let's say we have, okay, element 3. Okay. Element 3. Now, what I want to do is I want to express the element 3 as the bits, which is in our case will be 0, 1, 1. Okay. Now, how I'll do this, I'll explain. So now, look, now we have 0, 1, 0, 1, 1. Okay. Now, if I do 0, 0, 1 and I take a AND of this, what will it give me? It will basically check whether this bit is 1, because if for example, let's say this bit was 0. Okay, let's say if this bit was 0, then the entire result would have given me a 0, correct? But since this bit is 1, this too will be 0, but this 1 and 1 will give me a result 1, correct? So I know key in my last position, which is 0, 1, 1. I know that in my first position that I have a 1. Okay, that's fine. Okay. So now let's check in the second position as well. 0, 1, 1. Now I'll check in the second position. Second position also, I'm able to see that 1 and 1 will give me an OR of 1. So I can see that in my second position also I have a 1. Okay. And when I do 0, 1, 1, and then I OR 1, 0, 0, I'm able to see that here it will give me a result of 0. Correct. So 0. Now, if you are carefully able to see, here I have taken what? 0, 0, 1, 0, 0, 1. What is this? This is basically 1 left shift 0, correct? This is what? Your 0, 1, 0. What is this? This is your basically 1 left shift 1, correct? And this is what? This is basically 1 left shift 2. I hope everybody understood till here. Okay. So what I'm trying to do here is I am doing AND of VI, okay, with this. I'm left shifting J and I'm trying to check whether I have one bit in position 0 till 20 because you can have from 0 till 20, right? The number of bits in an element maximum. So that's what I'm doing here. I am checking bit by bit for every VI key whether there's a bit set or not in a particular position. So if it is equal to 0, I can say that at some value of j, my bit is set at j. So I'm increasing the number of bits at j. Okay. So in our case here we got it as 0, 2, 2. Sorry, the other way around. 0, 2, 2, which means in our first position we had two bits once, which is of 1, and then for 3 also, yeah, it was 0, it was 0, 1, 3, right? Our first subarray. So 0, 0, 1, 3. Okay. So for 3, it is 1, 1. So in the first location, we have 1 here, and from this one, we have 0, 1. Okay. So basically, it will be 1 here, sorry, because from 3 we have, from in the first position we have 2 set bits, and then in the second position we have only 1, which is from 3, and then here we have nothing. Okay, that's right. So now we know that OR can either have 0 or 1. So what I'm doing here is for every number that is greater or equal to 1, right? I'm changing it to 1. So my binary representation will look something like this: 0, 1, 1. And if you're able to see 0, 1, 1 is what? It's basically 3, correct? And here, if you have seen that 0, 1, 3 will give us an OR of 3. So that's how by sliding window, in the first window of, one second, I'll write down the question so it'll be easier to understand. So 0, 1, 3, we got the binary representation as 3, 0, 1, 1. Okay. So that's what I did here. I check whether it is greater than equal to 1. If it is greater or equal to 1, make it 1. And then I am storing this result in my set, okay, which is check bits. Check bits is basically I'm checking for every window of size mid, whether all are equal or not, okay. So I have inserted this, which is in our case will be 0, 1, 1. So I have inserted that in check bits, okay. Now what I'm doing is for 0, 1, 3, we have calculated the OR as this, which is 0, 1, 2, right? We will calculate as 0, 1, 2. Now, what I want to do is, I want to remove the effect of this 0 and I want to move the window one step front like this. Okay. So basically, I want to remove the effect of this and then I want to add the effect of this. Hope everybody understood. So that's what I'm doing here. we have a L pointer, which is basically in our case the first element, and mid is the element just after the size of the window. So what I'm doing is again I'm taking the bits, okay, of the left element, in our case 0, and I am subtracting it from the calculations we have done from the first window, because we have moved the window, right? Initial window was 013. Now I'm making the window as 132. So I want to remove the calculations of 0. So here I'm removing the calculations of 0 from V of L, and I am adding the calculations of V of R, which is basically I am doing OR with this 2. Okay. So just like how we did here, the same process I'm doing here, but here I'm just removing the L pointer, the element at the left of the window, and I am doing the calculations for element just outside the window so that I can move. Okay. Now we have gotten the new result in this bits, and then I am storing it in a temporary vector called temp. Okay. Now the same process as what we did here. If it is greater than 1, it will be invalid. So I'm converting it to back to 1. And then I'm inserting it in my uh, set that was check bits here. Okay. And now I'm moving the window. Okay. Now, if my size of this set, which is this set, is 1. So every vector that I've tried to put in the set will be the same, because set you cannot insert duplicate elements, right? So every element will be this thing unique. Every element will be the same. So I can say that this k or this mid might have been my answer. And I'm reducing my high by same mid minus 1. And if the size is not greater than, if the size is greater than 1, I can say that for some 2 or 3 or multiple subarrays, the OR was not the same. So by binary search, we are doing mid plus 1 and removing the low. And at the end, I'm just clearing these check bits because we have gotten a new high. So I'm just clearing it off. And at the end, we got our answer since we keep on updating this answer here whenever the size was 1. And that's how I did this question. There might be simpler approaches, but this was the idea that came to my mind during contest. So if any doubts, feel free to ask. Hello. Okay, so yeah, someone had to. Oh, okay, time complexity. Okay, fine. So, okay, so first, we're just taking your input as vector. So that is your O of n. Okay, we'll just take next line here. So now, okay, first we're taking an input of the vector O of n. Okay. Now we know that binary search will always take log n, correct? Binary search will always take log n. Fine. Now here, this part. Now for, let's say, in the inner loop, if you're able to see, the time complexity is what? It's only running for 20 times. So for this inner loop, I can say that it's basically running 20 times. 20 times is running. And for how many times? Until mid. So I can say it's basically into my mid, which is, let's say, M here. So this loop is basically running for mid times, 20 into mid times. Okay. This again, I'm just converting this, if it's greater than 1, making it 1. So that will again take 20, which is basically of 1. And now this, here what I'm doing is I am checking window by window, right? Like first this window, then next will be this window, then this window. So basically I'm checking for the entire length of the array, which is n, correct? So basically it was log n, your function, your binary search, and every time in that, what I'm doing is I am running it n times. One second, login. And for every binary search, however long the binary search goes, I'm doing the sliding window. Correct? So that should take your O of n, because by window I'm checking and I'm moving your R pointer until it is less than n. So I'm incrementing, so it should approximately take n times plus your rest of all. This was a constant. This took m into mid, which is one second. This took basically 20 into your mid, correct? Something like this. So 20 I can ignore and take it as 1, because O of 1, O of 20 is basically O of 1. So basically your time complexity will be something of like your n plus m times your log. And what is log here? Log is basically the this is basically size of your array, and m in this case is your mid. So in approx you can say that is n plus m log n, or basically O of n log n, approx. Okay, so it's n log n, and since the your time test case per limit was 2 seconds, so you had to use either some kind of n log n or O of n solution. So n O of n square would fail. So this was the n log n solution that we came up with. Okay. So sorry man.
राइट सो मैं सी का अब ले लेता हूँ. ज्यादा लोग बच्चे भी नहीं है, कितने हैं? 6 लोग हैं. Saitama Uchiha, nice name. Let me share my screen. अच्छा, सिंस इतने कम लोग हो तो एक बार एक थम्स अप रिएक्शन बता दो कितने लोग कल एक्चुअली इस प्रॉब्लम को एटलीस्ट अटेम्प्ट किए थे. कोई नहीं किया था. मैम, अच्छा किए थे. इधर किए थे, नहीं तो सब धोनी का बैटिंग देख रहा है. चलो, स्टिल इस क्वेश्चन पहले मैं एक बार एक्सप्लेन कर देता हूँ सिंस नेसेसरी होगा. तो क्वेश्चन में गिवन ये रहेगा तुमको कि एक इवन पॉजिटिव इंटीजर रहेगा, इवन है, एंड एक परमिटेशन n गिवन रहेगा, परमिटेशन p रहेगा गिवन ऑफ लेंथ n. नाउ परमिटेशन का क्या कॉन्सेप्ट है, ये है कि परमिटेशन इज अ नंबर. सो परमिटेशन इज अ नंबर, इज अ array where you have numbers from 1 to n. N is the size of the permutation, such that each number occurs only once. Like this 1, 4, 3, 2, 5 is a permutation of length 5. ठीक है, of length 5. It can be in any order, but the main thing is that every element occurs only once and every element must occur from 1 to n. So that's a permutation. Now, given तुमको करना क्या है क्वेश्चन में, पहले इस पे आते हैं. तुमको गिवन रहेगा कि एक ऐसा परम्यूटेशन क्यों खोजना है such that of length n such that the number of local maximums in the array a, एक array a बनाना पड़ेगा. एक array a बनेगा which would be something like कि तुम्हारा p है, p का एलिमेंट जितना भी रहेगा p1 p2 डॉट 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 pn, एंड array q रहेगा, q के एलिमेंट्स q1 q2 डॉट 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 qn. ऐसा रहेगा कि सम दोनों का जो सम आएगा that would be p1 plus q1 p2 plus q2 pn plus qn. This would be your array A. Okay, and you have to find, so क्या है, score of another permutation q is the number of local maximums in the array A of length n, where ai is equal to y. 3i plus qi in this. In other words, the score of q is the number of I such that for I in range 1 to n strict inequalities है, वो बता रहा हूँ क्यों है कि तुम्हारा लोकल मैक्सिमम क्या रहता है कि कोई एक एलिमेंट है, मान ले ए आई, तो ऐसा होगा कि ए आई माइनस वन ये ऐसा आना चाहिए एंड यहाँ पे आना चाहिए ए आई प्लस वन. This is what you need to do to get a local maximum. And effectively तुमको क्या करना पड़ेगा कि local maximums को maximize करना पड़ेगा in this array A. That would result in the highest score, and the highest score is what we need because in the end maximum score ही हम लोग को achieve करना है. So we need to find a permutation Q such that the maximum score for this is achieved. That is, for this array A, we need to get the maximum number of maximums. And वैसा Q चाहेगा. तो एक और इन सब टाइप के क्वेश्चन में एक अच्छा ऑब्जर्वेशन रहता है, हमेशा ध्यान देना. ये रहता है कि जब भी दिखता है ऐसा, if there exists multiple such permutations, you can pick any one of them. ये जैसे ही बोल दिया मतलब कि चांसेस है कि आंसर इधर बहुत आसान दिया सकता है, फिर बेसिकली ये बोल दिया तो ऐसा सीन है कि इसका आउटपुट पे भरोसा मत करो, वो हो सकता है बहुत खराब दिया हुआ है. बट स्टिल बाकी सारे केसेस गिवन रहेंगे. अब लेट्स टॉक अबाउट हाउ. सिंस n इज इवन, तो a का जो साइज आएगा वो भी इवन ही होगा. नाउ मैक्सिमम को मैक्सिमाइज करना है. व्हाट इज द मैक्सिमम नंबर ऑफ local maxima that you can get from an array of size n. Now, obviously बाउंड्री केसेस को तुम ले नहीं सकते, तो बाउंड्री केसेस पे जो भी एलिमेंट्स रहेंगे उनको तुम कंसीडर नहीं कर सकते, मतलब कि वो कुछ होंगे व्हाटएवर, डोंट केयर. बाउंड्री केसेस को तुम कंसीडर नहीं कर सकते, तो इट वुड लुक समथिंग लाइक दिस कि आइदर इसके बाद वाला एलिमेंट ऐसे मैक्सिमाइज हो गया एंड रेस्ट भी ऐसे मैक्सिमाइज करते हुए चलते गया, या फिर हो सकता है कि पहला नंबर से ये स्टार्ट किया, नहीं हो ऐसा हो एंड देन ऐसा हो जाए कि फर्स्ट नंबर ये, तो यहाँ पे तुम्हारा मैक्सिमम सी हो गया एंड यहाँ पे मैक्सिमम सी सारे हो गए. तो ये दो केस हो सकता है. बट टोटल नंबर ऑफ मैक्सिमम कैसे निकालेंगे? सो ब्रीफली बता दे रहा हूँ. टोटल नंबर ऑफ मैक्सिमम ऑफ लोकल मैक्सिमम will be equal to n by 2 minus 1. नाउ ये कैसे आएगा, इसका एक सिंपल सा एग्जांपल से बताता हूँ. लाइक मान लो कि तुमको एक एरे गिवन है 1 2 3 4, ठीक है, या फिर नंबर्स मत लो, बस ऐसे ही P1 P2 P3 P4 ऐसे कुछ भी गिवन होगा. सो मैक्सिमम को तुमको एक टोटल नंबर लोकल मैक्सिमम जो पॉसिबल हो सकता है, हाईएस्ट नंबर, अपर बाउंड निकालना उसका. तो लेट्स से कि तुम्हारा मैक्सिमा इसमें ऐसे रहेगा, ठीक है, या फिर ऐसे. तो मैक्सिमा इसमें एक ये रहेगा एंड एक ये रहेगा. इसके अलावा पॉसिबल नहीं है क्योंकि तुम बाउंड्री केसेस पे कंसीडर कर नहीं सकते, सिंस तुम्हारा यहीं पे लिखा हुआ है कि स्ट्रिक्ट इनइक्वालिटी है. दोनों में बाउंड्री केसेस तुम कंसीडर नहीं कर पाओगे. ये देखो यहाँ पे ये वाला 1 इज लेस देन, तो आई तुम्हारा यहाँ पे आ नहीं सकता. सो ये दोनों ये सारे बाउंड्री केसेस तुम्हारे कंसीडर नहीं हो सकते, तो खाली एक इधर आ पाएगा. इससे ज्यादा और पॉसिबल है इसमें उठाने हम लोग को लोकल मैक्सिमा. इफ यू सी देन पॉसिबल नहीं है. ऐसे तुम और साइज बढ़ा दोगे, लेट्स से 6 कर देते हो, तो P1 P2 P3 P4 P5 एंड P6 अगेन करते हैं वैसे कुछ ऐसा. हम लोग को अभी क्या काम करना है, मैक्सिमाइज करना है लोकल मैक्सिमम को. आइदर ऐसे बनेगा, नहीं तो ऐसे रहेगा, कुछ ऐसा जाएगा, ऐसा जाएगा, ऐसा जाएगा, ऐसा जाएगा, ऐसा जाएगा. यहाँ पे 1 2, यहाँ पे भी. तो टोटल दो आता है इस केस में. ऊपर वाले केस में 1 आ रहा था, इसमें 2 आ रहा था. Now if you see अपना फॉर्मूला क्या था, n by 2 minus 1. तो यहाँ पे टोटल n कितना है, 4 है. n is equal to 4 है, तो n by 2 minus 1 कितना हो गया, 4 by 2 minus 1 equal to आ जाएगा तुम्हारा 1. तो ऑब्वियसली 1 इसमें है. अगले में देखोगे n is equal to 6 है, तो n by 2 minus 1 will be equal to 3 minus 1 which is equal to 2. तो 2 है. So this gives us the total number of local maximum. अब पहले और एक पेज एक और इसमें ऑब्जर्वेशन बहुत अच्छा हिट मारने वाला ये है कि लोग है भी मीट में कितने लोग हैं? 1 2 3 4 5 बहुत कम हो गया। तो इसका एक और ऑब्जर्वेशन क्या बता रहे थे? हाँ, तो ये है कि ऐसे दो केसेस क्यों, ऐसे ही दो केसेस में बनेगा ये। पहला ऊपर से ऐसे आइदर ये केस कंसीडर कर सकते हो या ये कर सकते हो। तो इसमें अब देखो एक चीज, आइदर तुम्हारे जितने भी लोकल मैक्सिमा ऐसे मान लो उसमें इंडेक्सिंग दे दो 0 1 2 3 4 5, आइदर तुम्हारे जो मैक्सिमा है they will occur at the odd positions or the odd indexes if you are considering zero indexing one, or they will occur at the even indexes, even indexing. So यही दोनों में से कोई एक पॉसिबल केस हो सकता है। अब तुम पूछोगे कि हाउ डू यू नो कि यही होगा, आई मीन मैक्सिमम आ पाएगा या नहीं, कि कोई भी एक गिवन परम्यूटेशन को गिवन है, लेट्स से व्हाटएवर रैंडम परम्यूटेशन गिवन है, कोई भी रैंडम परम्यूटेशन गिवन रहेगा, यू विल ऑलवेज हैव सम क्यू, some another permutation queues such that you can get this kind of arrangement, this kind of maxima arrangement. इसको अगर तुम अप्रूव करना चाहोगे देन आई वुड सजेस्ट कि कोई भी ऐसे ही एक या दो रैंडम केसेस उठाओ फॉर सम शॉर्ट लेंथ ऑफ n, like 6 n is equal to 60 कोई परम्यूटेशन उठाओ एंड उसके लिए come up with some q which satisfies this condition, you will always get it. I will tell you why, because solution में ही समझ में आएगा वो। तो ये तुम्हारा हो गया। अब आते हैं सोल्यूशन पे मेन। सो मेन सोल्यूशन इज समथिंग लाइक दिस, एकदम बेसिक सा ग्रीडी सोल्यूशन है। टू बी ऑनेस्ट मेरे हिसाब से ये बी से काफी आसान है इफ यू गेट दिस ग्रीडी सोल्यूशन। तो टेस्ट केस से बताते हैं। टेस्ट केस एक ले लेते हैं, क्या है 1 2 4 5 7 6 8 3, यहीं पे ले लेते हैं। क्या 1 2 4 5 7 6 8 1 2 4 5 7 6 2 4 5 7 6 8 3। सो ये मेरा पी गिवन है। Now, अब मेरे को मैक्सिमा चाहिए। हाउ डू आई गेट दैट? पहले इसमें क्या करते हैं हम लोग कि जितने भी बड़े एलिमेंट्स है, लाइक दीज आर द बिग दीज बिग एलिमेंट्स में एक तरह से तुम क्या चाहोगे कि बिग एलिमेंट्स और लाइक हाईएस्ट पे पहुंच जाए। अगर वो हाईएस्ट पे होंगे देन ऑब्वियसली उसके साइड्स पे उसके छोटे होंगे एंड देन यू गेट योर मैक्सिमा। बट इसको ऑप्टिमली कैसे करें? तो क्या करो, पहले जो बिगेस्ट एलिमेंट इन द परम्यूटेशन पॉसिबल है, दैट इज द एलिमेंट इक्वल टू n, उसको पता करो वो किस कौन से बेसिकली इवन या ऑड इंडेक्स पे लाई करता है। सो यहाँ पे 8 लाई करता है, ठीक है। वंस यू नो दैट यू स्टार्ट एडिंग, आई मीन दैट कि जो क्यू के एलिमेंट्स होंगे वो तुम स्टार्ट करोगे डिसाइड करना। लाइक 8 यहाँ पे है। सो यहाँ पे तुम क्या करो कि जितने भी इसके बाकी इसी के इंडेक्स वाले हुए, मतलब कि जो भी क्या इंडेक्स पे ऑर्ड पे है, तो ऑर्ड इंडेक्स वाले भी जितने भी होंगे, ये होगा, ये होगा एंड ये होगा, इन पे तुम क्या करो कि n/2 + 1 ऑनवर्ड्स एलिमेंट्स इसमें ऐड करते चलो, ओके। एंड ऐसा करो कि 8, सिंस 8 इज द बिगेस्ट वन, यू ऐड दिस वन टू इट, n/2 + 1 इस पे ऐड कर दो। एंड जो रेस्ट है उसको like in smaller order, like this one is smaller than 8, so इधर तुम ऐड करो n/2 + 2, this one is smaller than both of these, so इधर n/2 + 3 ऐड करो, इधर n/2 + 4 ऐड करो, which is effectively here your 8 itself. So इस तरीके से क्या हुआ कि जो smallest element रहा in this particular odd indexing fashion, तो स्मॉलेस्ट एलिमेंट को तुम लार्जेस्ट नंबर जो पॉसिबल है दैट इज 8 उसको प्रोवाइड कर रहे हो, एंड इधर लार्जेस्ट है उसको n/2 + 1 जो इस रेंज में है उसमें स्मॉलेस्ट प्रोवाइड कर रहे हो, एंड देन यू गो अगेन। नाउ दिस टाइम व्हाट यू डू, कि तुम्हारे पास अब बच गया इवन इंडेक्सिंग वाले एलिमेंट्स। ठीक है, इसमें भी तुम सेम काम करोगे कि जो स्मॉलेस्ट एलिमेंट है उसको लार्जेस्ट पॉसिबल जो नंबर दे सकते हैं, दैट विल बी हियर n/2, वो दे दोगे। उसके बाद जो अगला है उसको n/2 - 1 दे दोगे। उसके बाद जो अगला है, वेट दिस वाज नॉट द नेक्स्ट, n/2 - 1, इसको n/2 - 2 दे दोगे, एंड इसको n/2 - 3 दे दोगे। Yes, so this one will be equal to 1. This way, this one effectively becomes a big number, and this one effective ये सबसे this one is the biggest, so इसको smallest दे दिए। So ऐसे तुम अपना क्यू अरेंज करोगे। नाउ एक और इसमें इंट्यूशन बता सकते हैं कि जैसे कि मान लो तुम्हारा 8 लिए, क्यू मैंने इवेंट वाला कंसिडर किया था पार्ट, कि 8 का हम खोजेंगे, क्योंकि जो ऑड इवन ये वाला केस भी उठा वो 8 की वजह से उठा। We saw that 8 was on the odd position, so 8 को मैंने ये वाला नंबर देना प्रोवाइड किया। ऐसा क्यों करेंगे? Let's say n is the 8 is the largest, that is n. So इसको मैंने क्या दिया? 8 को मैंने दिया n/2 + 1. Okay, and let's just say कि a का right या left whatever एक उसका नेबर है n - 1, that is the second largest element of P. इसको मैं क्या लार्जेस्ट नंबर दे सकता हूं? What can I give this one the largest number? Let's just say it would be n/2. Now कंडीशन क्या होना चाहिए कि ये जो है this one should be greater than this, and if you can see then this holds, so this approach is correct. So approach is pretty simple. I'll tell you guys once again. P मिल जाएगा, whatever elements है, you find the largest number, इसमें से you find n का लोकेशन। ठीक है, n का लोकेशन जो रहेगा उसको तुम ऑड या इवन जो भी है वो पता करके रख लो कि वो ऑड इंडेक्स वाला है, इवन इंडेक्स वाला है, इवन और ऑड whatever, you find it. Once you know that, then बहुत कम लोग बात की है। Once you know किस इंडेक्स पे है ऑड या इवन पे, देन तुम उस पे ऐड करते चलो n/2 + 1, मतलब कि सेकंड हाफ जो एलिमेंट्स है उनको ऐड करो, दैट इज अकॉर्डिंग टू देयर साइजेस। की लार्जेस्ट पे तुम ये ऐड करोगे, सेकंड लार्जेस्ट पे जो भी है सेकंड लार्जेस्ट उस पे तुम ऐड करोगे n/2 + 2, ऐसे ऐड करते चलोगे, एंड यू डू दैट फॉर दिस। सो ये फाइनल इससे तुम्हारा a बनेगा, एंड ये जो पार्ट रहेगा ये तुम्हारा q में जाएगा, ये पार्ट तुम्हारा q में जाएगा। तो अब एक बार मैं कोड दिखाता हूँ, उससे ज्यादा बेटर समझ में आएगा। तो देखो कोड में स्टार्ट किए तो ये पार्ट तुम्हारे पास इनपुट लेने का हुआ, ये पार्ट जो आता है ये क्या काम कर रहा है कि इवन जस्ट एक एलिमेंट, मतलब कि एक नंबर है, मैक्स एलिमेंट from all of the array minus arr.begin. So this gives like मान ले कुछ p1 p2 p3 है, मान ले ये तुम्हारा मैक्सिमम एलिमेंट है। ठीक है, तो what this part would give you is like 3 as result, क्योंकि ये तुम्हारा बिगिन यहाँ पे है, मैक्स एलिमेंट का यहाँ पे, तो आइटरेटर माइनस करोगे देन तुमको 3 आएगा। ठीक है, 3 देगा, 2 देगा, 2 देगा। हाँ, so this one will give you 2 as a result, क्योंकि देखो अगर यहाँ पे रहेगा 0, यहाँ पे अगर रहता 0 देगा, यहाँ पे रहेगा 1 देगा, यहाँ पे रहेगा 2 देगा। So this one would give you 2 and mod 2 कर रहे हो, क्योंकि अगर ये आगे रहता ये वाला पार्ट देन उससे तुमको mod करना पड़ेगा, बट सिंस तुम mod कर रहे हो will be equal to 0. So what this means, what this is trying to say, that this and this are on the same indexes, like ये even वाले पे आ गया, this belongs on the even part. So basically even में बोल रहा है कि 0 हो गया, वो just एक एलिमेंट है, that does not matter. उसके बाद क्या किया, एक तुम टेम्प एरे बनाए। ठीक है, मैंने एक टेम्प एरे बनाया, उसमें क्या किया कि सारे के सारे जितने भी इवन से स्टार्ट कर रहा है, यानी कि तुम यहाँ पे इन दिस केस तुम स्टार्ट कर रहे हो 0 से, 0 से स्टार्ट कर रहे हो, गोइंग टिल L विथ I + 2। तो बेसिकली सारे के सारे इवन एलिमेंट्स को तुम टेम्परेरी एरे में ऐड करते रहे हो, एंड देन यू रिवर्स सॉर्टेड। रिवर्स सॉर्ट क्यों कर रहे हैं? क्योंकि तुमको जब आगे स्टोर करना पड़ेगा, here you give the biggest element to you assign the biggest element to n/2 + 1। so reverse sort कर दिया, उसका बेनिफिट ये हो कि लार्जेस्ट एलिमेंट फर्स्ट एंड द स्मॉलेस्ट एलिमेंट लास्ट, वो किए, एक मैप क्रिएट किए। मैप तुमने क्रिएट किया, एक वैल्यू इनिशियलाइज किया n/2 + 1, ठीक है। तो उसके बाद क्या किया कि जितने भी एलिमेंट्स थे इन टेम्परेरी एरे, दैट इज 8 टू द स्मॉलेस्ट वन, स्टार्ट किया, एंड देन मैप के उस इंडेक्स के लिए वैल्यू प्लस प्लस करते गया। मतलब कि पहले में n/2 स्टोर किया, अगले में n/2 + 1, n/2 + 1, n/2 + 2, ऐसे से बढ़ते गया, ये अपने से आइटरेट बढ़ जाएगा। फिर तुम्हारा क्या किए है लास्ट में, BRR। ये BRR एक्चुअली तुम्हारा एरे क्यू है। तो क्यू में तुमने स्टोर कर दिया जो भी उस एलिमेंट के कोरिस्पॉन्डिंग तुमने क्या बोलते हैं वैल्यूज में बनाए थे। लाइक पहले में 8 की जगह पे आएगा n/2 + 1 विच इज इक्वल टू व्हाट, 4/2, दैट इज 8/2 + 5। तो 5 स्टोर कर दिया एंड अकॉर्डिंगली बाकी सारे एलिमेंट्स में वैसे स्टोर कर दिए। उसके बाद तुमने इवन को अब स्विच कर दिया कि अभी तुमने एक पर्टिकुलर इंडेक्स लाइक 0 इंडेक्सिंग के लिए किया था, अब क्या किया, ऑड इंडेक्सिंग के लिए करना है, तो ऑड इंडेक्सिंग के लिए स्टार्ट किया। देन यू डू दैट अगेन कि ऑड इंडेक्सिंग में सारे एलिमेंट्स को इनपुट ले लिया इनटू सम अदर टेम्परेरी एरे, सॉर्ट कर दिया। इस बार नॉर्मल सॉर्टिंग किया कि ये इनपुट छोटे से बड़े कर दिए है। फिर एक दूसरा मैप बनाए, वैल्यू तुम्हारा n/2 हो गया, क्योंकि अब तुमको स्टोर करना है कि n/2 एंड अकॉर्डिंगली लोअर जाना है विच इज स्टिल 1। स्टोर कर दिया, यहाँ पे भी वही किया, क्रिएट किया एंड डन हो गया। फिर तुम्हारा वही BRR में स्टोर कर दिया अगेन जैसे ऊपर किए थे एंड रिटर्न कर देंगे। सो दिस विल बी द इंट्यूशन फॉर दिस। ज्यादा लोग है भी नहीं, किसी को डाउट है तीनों में से? राइट, सो इफ नो डाउट्स देन एंड करते हैं।